Hey everybody, welcome to the first day of your review for your final. Now you might be thinking, all of my packets are in school. I don't know how I'm going to study for the final, and I know how you're going to study for the final. I know how we're going to review for the final. I have review sheets that you're going to get with all the information that you need on them. They're going to have practice problems and lectures to go with them, and some problems even that I work through. Then you're going to get a final review to do on your own, and then you're going to get a final. We are going through units 1 through 6, including pi, that weird little unit we did. Between now and when you take it, we've got plenty of time. It's only going to take a couple of days on each unit. You'll get to see the big ideas. If I don't go through it on these reviews, chances are good it's not going to be on the final. Right now, I'm thinking multiple choice the whole way through, time to do your math, and details to follow. I have multiple choice finals from the past. They've gone great. And we are going to get a nice chance to review. Like I said, gas laws, and then we have all the time in the world. We're going to get our finals out of the way before all the other classes do. It's going to be great. So we're starting with Unit 1. Unit 1 is when some of you thought chem was hard already, and some of you are like, this is a piece of cake. Unit 1 is the basics. Lab safety and equipment. Unit 1 is branches of chemistry, the scientific method, and then some number stuff. We've got some significant digits, which I know a lot of you want to go over. We've got a density calculation and some metric info. You're going to see as we go through this that some stuff we did, like metric conversions, aren't included on the final. There's just no room. There's too much from the year. So we're going to start with big ideas from lab safety. I know we didn't do a lot of labs, but the safety ideas are still there. When you're getting dressed for lab, you got to keep your goggles on. If you're going to be splashing chemicals around, you need to protect eyes. None of the stuff we were going to work with in Gen Chem was gloves or apron worthy. You might have been by and seen the AP Chem kids in their aprons and their gloves and their goggles and everything else, because the things that they were working with were things like hydrochloric acid, were things even like food dye that were just messy. For us, it's going to be closed-toed shoes, goggles on, and like this, hair pulled back, nothing loose, no necktie, no necklace. Just good lab safety clothes, mostly goggles on. As far as your basic first aid, don't get tangled up with other people's blood. Offer them help. Do not get into their mess. Other than that, a lot of what we talked about with safety and first aid is common sense. Be safe with fire was another big one. Clean up glass safely. The lab safety stuff I'd ask you on a final is the big ideas. Like, don't touch blood, don't throw glass, don't play with fire, that kind of stuff. For your basic lab equipment, I put up a list. What holds liquids? Remember beakers? They're the little short guys. Graduated cylinders are tall and flasks are shaped like my dog, skinny at the top and round at the bottom. You're not going to need to know what's best for what. You're not going to identify pictures. But how I have them sorted is what moves liquids and what moves solids. You've got your scrupula and your spatula, with scrupula sort of rounded, spatula's flat, they move solids, and forceps and tongs. Forceps are the little pinchers and tongs are the big. That kind of stuff is what I'm looking for if I were to ask you about laboratory equipment. We use the graduated cylinders with the pennies, so things that we used may come up more important than things we didn't. For your branches of chemistry, we divided chemistry into 5 things, and we had looked at some key words about what went with each one. Analytical is the word testing. I'm testing or I'm analyzing something. Biochemistry is reactions that are going to happen in living things. Photosynthesis and respiration are big examples of biochemistry that you learned in Gen Bio. Organic and inorganic are opposites. Organic is carbon. Look for the word carbon. Inorganic, look for metals or metal names. Now that we've done more work with the periodic table, I could be like, we were looking at the strength of titanium versus the strength of tungsten. Those are metals. Here's the one trick on that. If we are testing something to see if a metal's there, your best answer for that is analytical, because you're testing. And then for physical chem, we're looking at how fast reactions happen, or we're looking at changes in temperature. Those are physical chem. We did scientific method till it about came out our ears. We've done this in every science class, and people still get a little confused. First step is make observations. That was on the test you took in the fall, and a lot of people missed it. Your first step is to make observations, because if you haven't made observations, you don't even know where to start. Right now, if you ask me to form a hypothesis about the weather at York, I'm not at York. I'm at my house, which isn't at York. I don't know. I haven't made observations. I'd need to go online. I'd need to Google weather at York and see what's up. I haven't made those observations. I have no hypotheses. Hypothesis, we used to say educated guess. It's a best explanation for what we think is happening, like what's going on. After that, if you conduct an experiment, you're going to get variables. You're going to get an independent and a dependent variable. This is kind of confusing because independent seems like it should be elsewhere, and dependent should be like here. Independent variables are what is changed by the person doing the experiment. So I want to change the water in the corn plants. We did that in class. I want to give them more water. That's what I'm changing. Dependent variable changes because of the independent variable. Once you've gone through all of that, you're going to see if your hypothesis was correct. If not, you do it again. We try again. We rethink what happened. Maybe it was a condition that the experiment happened in. Maybe I want to water these plants twice as much as these plants, but then I stick them in my window, and like what's going to happen this week, we aren't going to have any sun all week, and it wasn't the water. It was the fact that the little buggers got no sunlight. So different things can affect it. Maybe that's why my hypothesis was wrong. Let's try a scientific method example. And it says on your worksheet thing, pause the video and answer the questions, and I'll go through them. Or keep it moving, and I'll go through them with you. I know some of you guys like either way. So we've got the question in your packet, and I'll do the questions now. So if you want to do it on your own, pause and try. If not, I'm going to keep reading. Nitrogen, potassium, and phosphorus are important elements in plant growth and are included in most fertilizers sold in stores. In most fertilizers you buy, I was buying fertilizer for my berry plants and was looking for a specific ratio, and it's listed on the bag in that order: nitrogen, potassium, phosphorus. I want to know if I find chemicals that are used in fertilizer and mix a teaspoon of each, if it'll help my berry plants grow. I'm working with my berry plants right now. They got their commercial fertilizer a couple weeks ago. They look like they think it's spring, even though it's going to feel like winter pretty soon. Again, more snow this week. I think that this will help them grow, so I divide my strawberry patch in half, and I water half with the fertilizer mixture and half with just regular water. At the end of the summer, the plants that have been watered with the fertilizer mix had grown bigger than the ones that were watered with regular water. My hypothesis is my guess, what I think is going to happen, and I think that the fertilizer water plants are going to grow bigger. That's my hypothesis. Before I formed that hypothesis, I did make an observation that commercial fertilizers have nitrogen, potassium, and phosphorus, and being a chemist, I probably looked at how much to see if a teaspoon would be enough, or if it's too much, is it even going to make a difference? My independent variable is what I changed: fertilizer in the water. Half got fertilizer, half didn't. Normally I just water them. My dependent variable, what changed because of the fertilizer, was plant growth. My hypothesis was correct because the plants did grow more. They all grew. The fertilizer ones were just better. So that's it for today. Those are your topics. At the end of this worksheet that you got, the chemistry review of Unit 1, there's a few more practice questions. There's another one of these and some examples of different branches of chem. Try those. When we're done with this packet, the rest of it's in the next lecture, the rest of it's for tomorrow. We're going to then look at, I guess it's going to be for Monday, we're going to then look at significant digits on in the next lecture, and after we're done with all of that, I'll put up the examples. I don't need these practice problems turned in, they're for you. The big review that's due right around the time of the final is something you'll be turning in. So that's it. Keep your eye on this review stuff, because this is where your mini quizzes are going to start coming from too. And that's the start. Day 1 review for final. Have a great day.